Okay, welcome to our first algebra lesson of the year. As you can see, I have my notes ready right here. Up on the top it says Algebra Lesson 1-1 and what we're talking about today, which is variables and expressions. Every time that I do a workshop and I film it, I'm going to tag my lessons this way. We're going to be working on algebra first for the year, and we're going to be working through pretty much straight through. So we're starting with 1-1 and we'll move on like that. I also put what it's about, what the standard is talking about that we're going to want to learn about today. And today it's variables and expressions. Now, we are a completely online digital course. However, when it comes to math, I really want us to make sure that we are taking notes on paper. We're saving enough trees by putting all of our work online. Let's go ahead and use paper so that we can write down our math notes. As I'm going through these math notes, you should be copying down exactly what I'm doing. That's the way we take notes here at OPA. What I'm going to do is what I write down, you should have a copy of that you write down. I'm going to go ahead and hole punch this at the end, and I'm going to go ahead and put it in a binder and keep it safe and keep it organized so I can refer to it anytime that I want, or hint, hint, wink, wink. Maybe if Mr. Berry comes one week and asks to see your algebra notes, you can pull those out and show him, and you'll get credit for that assignment. So I want the notes right here. You can go ahead and follow exactly the way I'm doing it, all right? I'm going to be writing down in my notes exactly how I want them written down. Now, when we do our workshops, I'll have it like this. When you have one that's not a workshop that you're doing at home, your parents are still going to be going through and making this lesson look like this, and you should take notes exactly like this. These are gate icon notes. We use the gate icons that we believe in here at OPA, and we're going to use those to help us see this content. So let's go ahead and get started. First of all, we always are going to title it this way. And what we do first, before we do anything else, is we do our first step, which is our anticipatory set. The anticipatory set gives us a way of looking at the material without actually writing down notes. It's not actually numbers and figures. It's sort of a way to get our mind wrapped around what we're talking about. So we're going to talk about a little bit. It's been quite a change for me, not the flood, that's been a change too, but it's been quite a change for me moving out to Colorado this summer. I always used to go back and visit Colorado, but now I'm actually living here, which is pretty crazy for me to be able to say that. Now, when I fly from Colorado to California, I always fly, and now I'm warning you here, I am not a good artist. So I always fly the same. Oh boy. Oh boy. Oh boy. Oh goodness. Oh my goodness. Okay, that's a terrible plane, but you get it. Mr. Berry, I always fly the same. Oh, I messed up the wing. Oh my gosh. Whatever. I fly the same Boeing 737. This is a Boeing 737. I fly the same Boeing 737 every single time that I fly out to California. Now, when I come out to California, I always get on the same flight, the same plane. On this plane, there are 190 seats. Now, I usually fly Southwest too, which they don't give you specific seats, so I have to make sure that I set up and get my check-in time early so that I can go in and get my favorite seat, which I always like the window. I always like being somewhere on the wing, on the window right there. But anyway, I get into this plane, and there's always 190 seats every time there. And then, for the most part, when I fly, so let's draw. Oh boy. Okay. Well, this is going to be the worst United States you've ever seen. There's Texas, there's Florida, there's Maine. Okay, well, so Colorado, actually, that's not as bad as I thought it was. So Colorado's about here, and California is sort of down here, right? So to fly from Colorado and you fly to California takes you about 2.5 hours. 2 hours, 30 minutes to fly from Colorado to California. Sometimes, now there are maybe times, you know, there's different air delays. Sometimes when you come into land, the most frustrating thing. So when you try and land and there's another plane on the runway and you have to circle the airport a while. So for the most part, it takes about 2 hours, 30 minutes. So two of the things that we're going to be talking about today, one of these is a variable and one is constant. Every time I get onto the Boeing 737, there's going to be 190 seats. There's not going to be one with 187 seats. If I get onto one and there's 187 seats, I'm probably not going to fly on that plane. But there's always going to be this many. But flying from Colorado to California, that won't always take 2 hours, 30 minutes. Sometimes it's a little bit more, sometimes it's less, depending on wind, depending on tons of different things. So let's move on now and let's talk about the standard we're going to be talking about today. Remember, this is an algebra standard. So the standard, now this is the part where you're going to need to make sure that you're writing exactly what I'm writing. This anticipatory set, I just like to try and fix my drawing by trying to draw that stuff, but we're going to go into our standard now. Our standard, which you should be writing down as well, is, now this is the hardest, most confusing standards that I've written so far. A-SSE.A.1a. So there we go. That is what we're going to be writing down. That's the standard we're going to be using as we work on our whatever we are going through today. The curriculum we're going through today is all based on this standard. So first of all, that doesn't make really any sense, right? So let's go ahead and look. What do you think this means? Or you don't have to decide what it means. I'll tell you what it means. So what we're looking at here is A stands for algebra. That's the kind of math we're in right now, algebra. This second three letters stands for seeing structure in expressions. So in algebra, there's a substandard, seeing structure in expressions. Now, in that substandard, there are three different things that we're going to be talking about. A1, A2, and then B3. Today, we're going to be doing A1, and not just A1, but we're going to be even more specific, standard A. So it's very confusing, and we're going to want to make sure that we write this down so we can think about it. But just know we're in algebra, we're talking about expressions, and then we're doing a substandard. So the standard we're talking about today, the one that we're all going to write down right now, is to interpret parts of an expression such as terms, factors, and coefficients. Okay, so that is our standard for today. Let's see, is that going to be better? No. Okay, so we're interpreting parts of an expression such as terms, factors, and coefficients. Types of different expressions. So that's our standard. Go ahead and have that written down. As you can see, as I'm going through my notes, I like to use a lot of different colors. I'm kind of spatial, and I don't like just looking at a page full of either black ink or pencil. I like to have these colors. Now, this is the greatest thing that Target sells, these incredible different colored pens. They should give me money. But, so I use this because I like to use my spatial intelligence and try and get some of this stuff down. Now, if you hate using colors, that's fine. You can use pencil or pen, but I would really recommend trying to work on your spatial intelligence and use these colors. So let's go ahead and get moving. The next step we're going to get into in our lesson is the big one, part where we actually learn the stuff, which is input. Now look at input. And in input, that's where we're going to write down everything that it is we need to know. And the first way we take a look at that is we use one of our gate icons. Our gate icons help us focus on certain things. It helps us identify where these things are and what they mean. And the first one we're going to do is language of the discipline. Now, Mr. Barry's not an artist. Those are supposed to be lips, not a cruise ship, not a red banana. I don't know. But these are lips right here. This is our gate icon for language of the discipline is words that we should know, sort of our vocabulary. So I'm going to go ahead and write down. We have a few to get through. We have about 4 we want to know. The first one is going to be quantity. So when you see this gate icon, you know you're going to be seeing some vocabulary, some definitions. So quantity, first one we're going to talk about is quantity. And quantity is anything that can be measured or counted. Anything that can be measured or counted. Now that's a lot. For example, 2 things that we can measure and count. We can measure and count seats on a plane. We can also measure and count flight time. Those are 2 things that we can measure, that we can count. I can count seats in a plane by pointing to them and counting them off. I can count my flight time in hours or in minutes, hopefully not in days. Now, some of these quantities are different, right? There are different types of quantities. So some remain constant. And some vary. So some remain constant, some vary. Seats on a plane, these right here, seats on a plane, that is very constant. You make a plane with a certain number of seats on it. It is constant. Flight time is definitely not constant. Flight time varies very much sometimes. So those are the 2 types of quantities we're going to be talking about. We have constants and we have variables. Constants always stay the same, variables differ. All right, our second term is going to be variable. Variable. You can probably tell by the way these words kind of look, variable and vary will have something to do with each other. So a variable is a symbol, usually a letter that represents value of a variable quantity. Okay, so a variable is a symbol, usually a letter. A lot of times you see X, sometimes you see A, that represents the value of a variable quantity. So we could say that the variable, we were going to make the flight time to LA. We wanted to make that a variable, sorry, LAX, the airport there. We could just say that that's N. So instead of saying 2.5 hours and being wrong when it's different, we could just say it's going to take us N amount of time. That means it can be a variable. It's a varying quantity. All right, 2 more, and they're very similar. The third one we're going to do is an algebraic expression. An algebraic expression. An algebraic expression is a mathematical phrase with 1 or more variables. A mathematical phrase with one or more variables. And yes, I do know that I have terrible handwriting, and I apologize. So, for example, we could say any mathematical phrase with one or more variables. We could say 2 plus x equals 3. That's an algebraic expression. 2 plus something equals 3. Or we could even do something like this. 2 plus, and remember, it just needs to be a symbol. And my favorite symbol to draw is the bat symbol. Equals 8. Doesn't need to be a letter. It doesn't need to be a letter. It just needs to be something that holds the place of a number you do not know yet. Now we can find out, obviously, 2 plus x equals 3. Well, x would have to equal 1 in this situation. 2 plus bat symbol equals 8. Well, bat symbol would have to equal 6. And next, our last one is going to be a numerical expression. Now, an algebraic expression is a little bit more complicated because it has that symbol in there. A numerical expression is just a number phrase with no variables. You're only using numbers. So our example here could just be 3 plus 5 equals 8. That's a numerical expression. No variables, no nothing, just simple. All right. So I'm going to move on. I'm out of room on this paper, so I'm going to switch to a new one. Everyone should still be following along with this and getting all of those terms down. Good thing about this being online is that you can always pause and go back if you didn't get enough time. And now we're done with our language of the discipline. So we're moving into a different icon, and this icon is a flower. And this is what we call details. This is where we know all our terms now. Now we just want some information. So the first thing we're going to go into here in our details is writing expressions for words. So we want to see expressions, but math can be described through words. Can definitely be described through words. So if through words I said that there's going to be a number that is 22 more than n, we can take that and we can interpret that and we can understand what it's meaning. So if there's something that is 22 more than n, I'm going to use orange and blue here because the Broncos are fantastic. And I'm going to create a visual representation of that. Those of us who are spatial, this is going to be nice. Those of us who are linguistic, that might be nice. Spatial, linguistic, we're all using this to learn our math. Now, what we can do is say n is this part, 22 is this part. This is what we're asking about. Now, we don't have to solve this because we don't have enough information to solve it. We just want to see that that's what it's asking. 22 added on top of n, which would give us n plus 22. If we want 22 more than n, that means it's an addition problem. And that's going to be our answer right there, n plus 22. Now, as we can see, that was all because it said more than. Let's look and see at a different one. If it says n less than 58, n less than 58. Now, It's not saying more than, it's saying less than, meaning it's going to be a different operation, subtraction. So on this one, our graph or our graphic is not going to be able to look the same as what it looks like right here, because now it's saying n less than 58. That means we have the number 58 and we're having n less than that. So first of all, I'm going to have to go ahead and say this right here is 58. Then my box underneath, this is a good way to keep everything organized. In my box underneath, I know that I'm taking n away from it. So this part right here is going to be what I'm looking for. And we can write that by saying there's 58, we're taking n away, and that equals what? 58 minus n. So that's pretty simple. The rules, and I'm going to be putting in another icon right here. This is one of our icons as well. When we come to things that are rules, these words that we're writing down, and that's our icon for rules. These words that we're writing down fill into these rules. More than gives us plus. Less than gives us minus. Now there's other ones we have too. You could say 7 times a number n. 7 times a number n. This time, that word we're looking at is times, which is multiplication. So that means we're going to have n 7 times. So our little image for this can be n, 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 because it's 7 times a number n. This is 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, and 7 times. And then what we'd be looking for is how much is all of that? 7 times a number n. Now in this one, there's several different ways we can write this. Yes, the simplest one, the one that we probably learned the earliest, is 7 times n. But when it comes to variables, there's other ways to show multiplication, and with variables, there's other ways to put it up to a number. So we have 7 times n. There's also 7 dot n. That's the same thing as saying times. And then finally, with a variable, you can just put the letter and the number next to each other. And all of these, this one, and this one, would all be representing this. 7 times n. And we have one more we haven't talked about now. And on that one, we'll say the quotient of a number n and 5. So the quotient of a number n and 5. And when it says that of a number n, it's just saying whatever this is. So the quotient of a number n and 5. So that means, let's think about what the word is saying here. First of all, it's saying quotient, which we should know that that means division. The quotient of a number n and 5. We have a number represented by n, and that number is going to be split into 1, 2, 3, 4, 5 pieces. So whatever number fits in there is going to be what we're looking for. So this can be written out as n divided by 5 or n over 5. So now to solve any of these, you just need to choose a number to fill in for n. So any of these we can choose to figure out by just substituting a number in for n. Because since n is a variable, it can be anything. We're going to figure that out. So let's go ahead and just solve any of them. Let's take this one, 7 times number n. So let's say that we want n to represent 4. 7 times n. If we're saying that n is going to be 4, it's just going to become 7 times 4, which is going to become 28. It can be any number. You're just filling it in. All right. Now, that's for one operation. That's pretty simple, just to get the one operation done by reading the words. But now, what if we have more than one operation? More than one operation. So let's say this time it said 7 more than twice a number x. Okay, 7 more than twice a number x. So those terms that are giving us those rules that we're looking at, 7 more, so more than, and also twice. We know what twice means as well. So here we're going to have to sort of think about our order of operations. What's going to come first? What's going to come second? So this one's saying 7 more than twice the number x. That means the 7 has to be added after we get twice the number x. So since our order of operations show us that multiplication will happen before addition, we're okay to just write this in. 7 more than gives us an addition sign, twice a number x. So our expression can be 7 plus 2x. We would multiply 2 and whatever number fills in for x, and then we would add 7 to it after that. Let's try one more like that. How about the product of 4 and the sum of a number, and then again, I'm going to go ahead and put the bat symbol. So remember, a variable can be anything. So now I'm looking for the product of 4 and the sum of a number, bat symbol. Oh, I'm sorry, I didn't finish it. I only did one operation. The product of 4 and the sum of a number, bat symbol, plus, let's say 7. There we go. The product of 4 and the sum of a number, bat symbol, plus 7. So on this one, we have to really use our order of operations and understanding what's coming first. The product, which we know product would be a multiplication problem, of 4 and the sum of a number, bat symbol, the sum, plus 7. So in this one, the product is going to be multiplied, or the 4 is going to be multiplied by the sum. So the addition problem has to happen first. So you may go ahead and write out 4 times bat symbol plus 7. You can look at that and say, oh, that has all the pieces there, right? The product of 4, the sum of a number, bat symbol, plus 7. But this one, our order of operations tells us that 4 and the bat symbol would be multiplied first, and then 7 added to it, when 4 needs to be multiplied to the sum. So we just need to go ahead and know how to approach this situation. So first of all, go ahead and cross that off. We don't need that. 4 is going to happen afterwards. So how do we group things so that they happen before multiplication? Well, the first thing that we want to do is get it into parentheses. Parentheses is one of the first things that we do. So now we have the bat symbol in here, plus 7. So now we'd have to look and do what's in the parentheses first before we multiplied, and this is going to be our answer. So we just need to be very careful about how it's phrased and the order that it would be. All right, again, I'm out of room, so I'm going to be moving on. We have one more section to get to here before we get to some examples. So I'm going to be moving this. Again, you should be keeping this organized somewhere. I'm going to put this with my first page. Okay, so we've talked about taking our expressions, whether it's one or two different operations, and putting them into expressions. But what about the other way? The other way of using words. Using words for expressions. I've already done this the other way, so we're just going to go ahead and do the opposite way now. So using words for expressions. First of all, let's do this nice and easy. If we just have a very simple problem or a very simple expression of 3x, we could say what? We could write down that this is, there's several ways we can write this down. 3 times x, 3 multiplied by x, and the product of 3 and x. Each of those is talking about this. Each of those. Now it seems pretty simple. You can probably tell that these get a little longer than that, but let's look at the reason why we never use words when we're doing this. It's very cumbersome and it's very difficult to know what you're meaning. What if we had this, 3x minus 4 in parentheses plus 14 divided by 6. If that was our expression, that would be a whole lot harder. You could say, okay, so 3 times the difference of x and 4 plus 14 divided. It's going to be a nice long sentence. So at this time, I want to go off here on the side. We're going to put in another one of our icons. And this icon, actually we'll put in 2 icons. This one is our across disciplines, which means anytime that we're talking about something that can be put into 2 different categories, math and social studies, language arts and science, we can go across disciplines with this icon. The other icon we're going to be using is the unanswered questions. This is when we really got to think about something. There's not just a flat out answer. There's not a yes or no. There's not an easy answer. You'd have to figure this out and put together some information and some research. So these 2 things, I want to ask one question. Based on what we're just talking about right here, why do you think nearly every civilization on Earth has developed a numerical system? Now, the unanswered question part of this is probably pretty simple, but if we look at this, 3x would in words be this. This written out in words would be much longer. So why do you think almost every civilization on Earth developed a numerical system? This crosses over a little bit into social studies, a little bit. We have our unanswered questions right there. So that's just something to think about as we're looking at this, as we're looking about how to use words for expressions. That's all we're going to talk about with words on expressions, but we are going to do this part now where we're going to come in for some rules. All right, and let's go ahead and draw our rules icon, which let us know that we have some rules we're going to be talking about. Okay, and variables are used to show rules, different mathematical rules. We use variables to understand. So because it's football season and I love football so much, we're going to frame this a little bit around football. Are you ready for some football? Woo! All right. So variables are being used to show rules. So let's go ahead and see what I'm talking about here. I'm going to go ahead and draw a little football field over here on the side so we can sort of see what I'm talking about when we're doing this. Okay, so let's just say this is the field. Yes, I'm not an artist. I understand that. So there's the end zone right there. In the back of the end zone, you always see the goalposts. The goalposts where you try and kick a field goal through. Oh, that's a bad drawing of whatever. You understand. So they're there, and you have to try and kick the football through here to get 3 points. So if we look, when we set this up, or when it's set up like this, there are 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. Okay. So we have some yards. Football fields are marked in yards. The end zone is 10 yards. 10 yards. And then each of these lines right here represents 5. This is the 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. All right, we'll stop there. So this is midfield right here, the 50-yard line. Okay, so this is a football field. Now, if you watched football this weekend, you saw that the Denver Broncos won. It was incredible. But not only that, their field goal kicker did something pretty awesome. So a kicker for the Denver Broncos, if you want to know, his name is Brandon McManus. Yes, that's a great name. Great name, McManus. Kicks field goals from 7 yards behind where the ball is snapped. So that's not the only thing we need to keep in mind. Also, the goalpost is 10 yards past the goal line. Okay, so now this is part of our rule, part of what we're going to have to figure out and use numbers to represent. Okay, so what we need to look at, what the question is, what is the rule for the full distance the ball must travel to the goalposts? Okay, so that's a long thing to write. I understand, and I'm sorry, but algebra likes when we do things like this. So I'm going to go ahead and put a chart, because when we get a question like this, that's a lot of words and a lot of things we're going to have to think about. So we're going to make a chart. We're not going to fill anything in yet, but we're going to make a chart. So the ball location is one of the things we're figuring out here. And the other is the distance in yards to the goalpost. So there's several things we need to understand about this situation. If we're looking at the field, let's start with something simple. Let's start with the simple one. If the ball is sitting on the 5-yard line, okay, so the ball location is the 5-yard line. The ball does not need to travel only 5 yards because this is not where it's being kicked, and that only 5 yards would go there. So if we look back up here, there's a few distinct rules we need to make sure we're listening to. So Brandon McManus, the Broncos kicker, kicks field goals from 7 yards behind where the ball is snapped. Okay, so this is where the ball starts. We need to figure out what 7 yards it's going to add 7 yards to that distance. Also, the goalpost is 10 yards past the goal line. So 5 yards from here to here, but then there's 10 yards from here to here. Okay, so if the kicker, if Brandon McManus is kicking from the 5-yard line, he's going to kick, first of all, how far he is from the goal line, 5 yards, plus how far he stands back, 7. And then that must be added. You have to add 10 yards to it. Okay, so now we can look at it in numbers. Now, what if he was on the 10-yard line? What if he had the ball here? He would have to go back 7 yards still, and he would still have those 10 yards. So our rule or our equation could look like this. 10 plus the 7 yards he goes back plus the 10 yards of the end zone equal that. So you're starting to see a pattern here hopefully now. So what if he was on the 15-yard line? 15 plus 7 plus 10. What if he was on the 20-yard line? 20 plus 7 plus 10. Now, you can see the pattern here. So my next one, I'm going to say n. For any location, no matter where he is, what's the rule we can use? Well, 5, 10, 15, 20, that's the variable distance. So we're going to put n, and then we'll put it in our constants. So our rule is going to be n plus 7 plus 10. That's going to be our rule for how far the ball must travel. Any distance plus 7 that he steps back plus 10 that has to go past the goal or go all the way to the goalposts. That's going to be our rule. All right, so that's one of them right there. And again, I'm out of room. We're going to move into almost our last part of our notes right now. That's all we need for input. So now we're going to go into modeling. And modeling is where we put down some examples. And I want you to write down these examples exactly as I'm writing them down, because you'll see some of these in the hint, hint, wink, wink, homework and tests. So let's go ahead and get started on our modeling. I'm going to model exactly how you're going to want to solve these. First of all, we're going to say, for these first couple, what is the algebraic equation? What is the algebraic equation? If we're not sure what algebraic equations are, we go back to our first page of notes where we have our language of the discipline. A mathematical phrase, oops, there we go. There we go. A mathematical phrase with one or more variables. So, what is the algebraic equation of the ones I'm going to put down? Number 1, the product of 7 and a number n. Okay, first of all, this one should be pretty simple. It's only one operation, and we just have to think of it, the product. We know what the product is going to be asking for of 7 and a number n. So simply, it's going to be 7 times n, or 7n. So that's pretty simple. One operation, shouldn't have much trouble with that. Number 2, let's get into more than one operation. The sum of 4 and a number n times 4. So the sum of 4 and a number n times 4. So this time we're going to have sum and times, and we have to figure out what's going to happen first. Are we going to have to multiply both of them together or multiply first? So it says the sum of 4 and a number n times 4. So it has to be the sum that we're multiplying. So if we have all the things figured out here, 4 plus n times 4, we need to figure out where are we going to need to put parentheses or anything else. So if we look here, we do need to have multiplication first. You can put those around if you want. Whoops, I did that completely wrong. Hopefully you caught that. 4 plus n times 4. We want the sum first. So sorry, I got to put my parentheses around the wrong places. There we go. That's going to be our answer for that one. Sorry about that. Number 3. Number 3. What is the rule for this pattern? What is the rule for this pattern? We're going to be talking about a rental car, okay? So this is a rental car. If you're renting a car, the cost of it depends on the number of miles you drive it. So on one side, I'm going to have the number of miles. And on the other, I'm going to have the cost. Okay, so here we go. I'm going to give 1, 2, and 3. If you're renting just for 1, 2, or 3 miles, and then we're going to try and make the rule after we do this. So for only 1 mile, it's going to be $49 plus 75 cents times 1. If we're going for 2 miles, the cost is $49 plus 75 cents times 2. And for 3, $49 plus 75 cents times 3. So again, should be pretty simple for us to be able to see what is the variable that we see here. What variable are we looking at? And the variable number is the number of miles. That's what's changing. So our rule is going to be $49. You're always going to pay that $49. And then you're paying your 75 cents times however many miles you drive. So it's 75 cents a mile. And that's the end of our modeling there. So 3 examples of how we're doing some stuff. Now, before we end, since we're in algebra right now, we don't go to front row ed. Normally we will do some front row ed. That's a great way to go for your 8th grade standards. However, we are going for algebra. So when we do our guided practice, our guided practice is going to be out of the online book. So if you go to the online book, you'll be able to go to lesson 1-1, and you'll be able to find that it's the same information we've been going over here. And then your practice and problem exercises. And on that page where you see the practice and problem solving exercises, you're going to do number 9 through 25, and you're just going to do the odd numbers. Then once you finish that, that's your practice, and now you're going to do some independent practice. On your independent practice, you're going to go again, you're on that online database, right? You're on the online book, and there's a button for you to click that is interactive digital path. When you go to the interactive digital path, you are going to go to lesson 1-1, and you are going to take, there's several options there. You can review any of it if you want, but what I want you to do is the self-assessment. The self-assessment, and that's going to help you see how you understand this material. And you can always review the resources that are there as well. There's plenty of stuff there. But this is our first math lesson. We are done. Thank you very much for joining me. I will see you the next time we have our math workshop. Have a great day and go Buffs.